Alright, so we're back. We're back. We're back. We're back. We're back. Check, check. Check, check. Cool, cool, cool. Alright, so we finished the basic logic, we finished the arithmetic. Now we're into the computer architecture mode. So the registers one was pretty tricky, I think. So we've got a value here. And then copy input to output. So okay. So we need to bypass. So we could probably use ALU. But that's not what we want. What we're going to do is we're going to say if we have this one and this one and this one and this one, and we want to trigger this switch. That just copies the input to the output. It should copy the input to the output. Output is not enabled. So register 0 would be I feel like there's a better way to do this, but let's say this would be 1. Not 1. So not 1. It'd make more sense to do these on the output actually with multiplexers. But I'm gonna have more fun doing it the wrong way at first. You always refactor logic later. So not 1. And 1. Not 2, not 3. Oh wait, this is the save line. Okay. Let's register 0. I actually really like this design so far, even though I know it's not the best way to do this. Copy input 27. Register 0 should have. Is this not register 0? Or is this register 0? Let's just test it out. That's register 0, so how is that not? Register 1. Register 2. Register 3. Register 5. And there's no register 6. 6 is output. Which would be this one. We'll have to fix this because it'll break. So this is our load line and our save line. And then this is our bypass. So this only turns on if we have all of them on. Register 0 should have value 27. I don't understand why it doesn't though. Man, these spammers are crazy, bro. How are they doing the registers? These are input states. These are output states. I see. Okay. Because we're not hitting the in. Because we don't need this in. I see. We don't need the switch. We'll have to fix this switch later, but I see. Okay, so and this one would be we messed up this line too. Okay. That's another problem we would have had. And then what we can do is move all of these way over here. And then we'll do the same thing here. do the same thing for here. So this will be the 1. We're gonna make these things real tight because we don't have a whole lot of extra space. The music in this game is pretty great, just gotta say. Okay, so we're making this as tight as possible. Something else we can do. We can copy all of this logic again. And just move it up. And then we'll connect this to this line, this to this line, this to this line, this one to that line, that to that line, and then this will be our save, and this will be our load. This will be our save, and this will be our load. Again, save and load. Save, load. Oh, we're missing the last line. Save and load. And what we'll do is we'll copy this sucker down here. And then this guy becomes we got something wrong. I think this one's supposed to be not the first one, and not the second one, and then this one is supposed to be the first one. We'll see in just a second. We'll be able to test this. And this one should be not the first one. And this one should be the first one. So let's just go through and test it. So this should be the first one, second one, third one, fourth one, fifth one, and sixth one. And same for here. R1, R2, R3, R4, and R5. So these instructions work. But we need to add one more thing here. So we need a 3-way AND instead of this 2-way AND. And same thing here. we need a three-way and instead of this two-way and we need to say not and not. So this bypass only works whenever specifically this in and output are triggered. So copy code in let's see. Do we have a decoder? We actually do have a decoder. Oh, you know what? I see what the problem is. This enable and disable has to come from this input. So what we're gonna do is we're gonna use, can we reset? Is there a reset button? We'll just do this. Alright, let's try this again. Let's use this decoder, 3-bit decoder. We're going to use it twice. So the first one will go to save, second one will go to save, third one will go to save. Let's do it like this. First one, second one, third one, fourth one, fifth one. First one, second one, third one, fourth one, fifth one, and then the sixth one. this value will just come up to all of them. And then the last bit will be our enable bit. And then I don't know if this will work right, but we can try it. Then our first bit let's change the color a bit. We'll do a different orange. So first bit second bit third, number 3, number 4, number 5, number 6, and then this is our enable line. So this matches the input to the output. Copies 27 into register 1. Into register 2, or 0, register 1. This copies register 1 to the output. This saves register 3. Oh, I see what the output line's doing is it's disabling the input, which forces us to read a value from one of these. Potentially, anyway. Register 3 copies register 3 to load out. Register 4, register 5, looks like we passed. Finally. Instruction decoder. Let's try this one. The circuit you built in the registers level can copy values between registers, while the arithmetic engine can do different operations on 2 inputs, but you need to be able to do both in the same circuit. To do this, build a decoder which will decide which mode our computer is in based on the 2 bits we have used. To distinguish between the instructions of 4 different kinds, the 2 bits, highest bits we use to determine which mode. Immediate, calculate, copy, condition, determine the mode we're in based on the input, then set to the right output. So, we can just use 8-bit splitter. And it's just the last 2, right? So then we have a decoder. And a decoder. So immediate would be there's probably a better way to do this, but this might be the fastest way, I don't know. 1 and 2. 1 1 and 2. Helps if I connect all of these. One and 4, and then 2 and 4. Instruction decoder. There we go. Calculations. Let's see if we can use this. Here's the decoder. It takes in binary signal and gives 4 outputs. Time to merge in the arithmetic engine circuit you made previously with the register circuit. The calculation circuit was saved in the component factory and can now be added as a component. If you forget which pin does what, check the circuit in the component factory. So the decoder takes in the same thing. I'm gonna have to take a break on this. My head has had enough for one day, y'all. We've gotten pretty far in this game, though. We're in the computer architecture now. Let's look at these conditions real quick. Maybe this one's one more we could knock out. This level has a value input in 3 conditions bit. 3 condition bit input. Now we're building our Boolean logic. So these are not, and these are. So, wouldn't this just be a switch? Like, if value equals 0, output green. What? Bro, I don't even know how to do this. This legit hurts my head. Bit 0 on. So, so there's 3 bits here. We need to have a decoder. No. Let's use a bit splitter and look at this. I feel like there's multiple conditions here too. We could use decoder here as well. So this would be this switch. Oh, what? I'm so confused. Yeah, I'm gonna have to hop off here. Oh, check this out. Okay. Interesting. Oh, I can't do this. My head hurts. Yep. I'll have to come back to this. I think we're on the right path, though. Like, these are probably the harder parts, too. I mean, obviously, like, the higher up you get, the harder this gets. But it's funny because some of this actually gets a little bit easier. Like, the phases of this are a lot easier. We've gotten through the logic. Let's see what components we've got. Component factory. How do we pick? Oh, sandbox. Component factory. This is our ALU. I don't know what it's doing. Doesn't look like it's doing anything other than just running up ticks. Oh, switch schematic. Okay. There's our decoder and our ALU. We could build new schematics, which is cool, but yeah, I don't know. Alright, y'all. There's our decoder. Pretty straightforward, I think. There's our decoder. Our ALU looks like that. Why does it look like that? Can we, if we bring these in, then we could make this thing a little more compact. I think it's still gonna stick out though. We'd have to like bring all of this in one. I still don't know if that's gonna get us in there. I think if we bring this back one more too. We could bring both of these back. This is a little unnecessary, but did this save us any size at all? Almost. Don't have anything here, but that's fine. We could rotate this thing. Actually, I think I would like to do that. Rotate this thing. Bring all of these down. Come on, man. Bring all of these down. And then we'll bring this guy here. This is 1, this is 2, this is 3. Now what's our... Yeah, look at that. Decoder and ALU looking clean. Now what's it look like? We got decoders, 1 block. The ALU is the size. Interesting. Doesn't get a whole lot cleaner than that. A B. Yeah. Anyway, we're gonna call it. Thanks for tuning in.